Hello and welcome to this Java DSA tutorial. So in this chapter, we'll see how you can represent your graph using adjacency representation. All right. So vertices in a graph are said to be adjacent to one another if they are connected directly by a single edge. So A is adjacent to E, A is adjacent to C, A is adjacent to B as per this graph, right? In this graph, we have 5 vertices A, B, C, D, E, and out of that, this A vertex is adjacent to B, C, and E. If we take E, then it is adjacent to D and A. And since it is a undirected graph, so B is also adjacent to A, right? But A is not adjacent to D since there is no direct connection. So that is what we have to represent programmatically. Now, first question is why use adjacency representation? Now, if you see, graph is a non-linear data structure, just like tree. But tree at least has some predictability because of some rules that at least in binary tree, you will have only two children at most, right? But graph does not have that kind of fixed structure. Any vertex may be connected to an arbitrary number of other vertices. That is what can happen with graph. So it is a little difficult to represent it, and you need a efficient way to actually represent it. So the two most common method to represent a graph is using adjacency matrix and using adjacency list. And you have actually four combination. If you see, you can have a undirected and unweighted graph, you can have a undirected and weighted graph, you can have a directed unweighted graph, directed weighted graph. So four combination, and for that again you can have adjacency matrix representation or adjacency list representation. So 4 into 2, 8 programs we'll see in this actually. That is why in this chapter we'll only do for unweighted graph. Now, if you have to show a graph representation using adjacency matrix, and this is for unweighted graph. So adjacency matrix actually is a 2D array in which you will use 0 and 1 to indicate whether an edge is present between two vertices or not. So 1 indicates the presence of an edge between two vertices. 0 indicates no edge exists. And if your graph has n vertices, then your adjacency matrix will have n rows and n columns. Your matrix will be n by n, right? So here, if you see, we have 5 vertices. That means the matrix will create, or the 2D array will create for this graph will be of size 5 row, 5 column, 5 by 5. All right. And that is how it will look like, your adjacency matrix. Since A is connecting to B, C, and D, so you see 1 for B, C, and D, other two are 0. And it is undirected, so A is connecting to B, that means B is also connecting to A, so this will be 1, right? And B doesn't connect to any other vertex, so all other are 0. E connects to D and A. E connects to D and A. So that part is 1, others are 0. So adjacency matrix actually is easy to implement and efficient to access the element. You just need, right, that row and column. So adjacency matrix IJ, you can directly access that way. But it takes more space because you are capturing all the data, whether there is a connection or there is no connection, right? So in adjacency list, actually, you will store only actual connections. But here you will store all the data. So that way it is less space efficient. So that is one thing about adjacency matrix. With that, let's implement a graph representation with adjacency matrix. All right. So here I have a new package com.netjstech.graph. In this, I'll create a class. Let's name it unweighted graph adjacency matrix. All right. So this bigger name. So what you need here is, of course, you have to pass the vertices of that graph. So that is one thing. Then you also need a matrix to represent it. ADJ matrix. And I'll create one constructor here where I will pass the vertices. How many vertices are going to be there in this graph? Then I can do this dot vertices equal to vertices. And adjacency matrix also I can create now equal to new int. It will be of the same size, right? So row and column both has vertices. Now what we can do is we have to create that adjacency matrix. So public add edge, which will get source and destination, right? Source to destination, that's how we have to map, right? What we can do here is we can make a check also. If source less than 0 or source is greater than equal to vertices, that means you are going beyond your array. Same thing we can check for destination also actually. So destination less than 0 or destination greater than equal to vertices. In that case, you can throw an exception or just so you can throw exception or show a message. Let's just show a message. Invalid edge addition and return. If you have passed that one here, it's okay. If I'm here, that means my source and destination are correct. Then what I can do is adjacency matrix that source and destination is 1, right? And for undirected graph, I have to do the reverse also. For undirected graph. So this will come here, will go here. Right? Reverse also is true. That is what we have to do. Now, if we have to create a graph, what we can do is we can first create a object of this created graph adjacency matrix. Let's name it object only, new. Here I can pass. So if we take the same graph, we'll have 5 vertices. So 5 I'll pass here. So it will create vertices 5 matrix also. Now I can start adding edges to it. So add edge. So this is our graph. If we take this as 0 here, 1, 2, 3, 4 like that. So we need for a 0 to 1, 0 to 2 and 0 to 4. That is what I can pass. 0 to 1, 0 to 2 and 0 to 4. Then from C it is A and D. C is 2, right? So A1 is already captured from this one, A to C. I need only this, C to D, 2 to 3. Then from D, there is 1 to E. So 3 to 4. That will capture all the edges, right? 1, 2, 3, 4, 5. Okay. Then let's also create one more method to print our graph. So display graph. What we can do is for int and run a nested loop. I less than, this is I plus plus, and then within that for loop int j is equal to 0, j less than vertices j plus plus. Within that print Adjacency matrix I and j. Let's give some space for that. I'll use tab. So that will be one line. Then we can move on to next line. So here I'll remove this. So once we create that, then I can call display graph to see how it looks like. And just to make it clear, this is A to B, this is A to C, this is A to E4, right? 2 means C to D, this is D to E. So these are the connections we have captured here. So that is what I'll get. A to B, C and E, right? B only A. C, A and D. A and D. D with C and E. D with C and E. And E with A and D. E with A and D. So that is how your adjacency matrix looks like for a unweighted, undirected graph. All right. So these are your methods for adding an edge, displaying adjacency matrix, and that is how you will run it. All right. So what we saw was for undirected graph represented as an adjacency matrix. If you have a directed graph, then how will you represent it using adjacency matrix? So in directed graph, your traversal is not both ways. Connection is not both ways actually. That is directed by this arrow. So if we have an arrow like this, that means I can go from A to B, but B to A is now not possible. Correct? Same way A to C is there, but not C to A. A to E is there, but not E to A. So this will still remain same. From A, I can go to B, C, and E. But now if you see, from B, I can't go to A. So B is all 0. From C also, I have only one connection to D. Correct? So if we have to represent it, actually what we have done, this one, right? Where we had captured for undirected graph. Only thing we have to change is comment this thing, where we capture the reverse direction also. That's it. Now it is for directed graph. So B is all 0. C is only connected to D. Right? D is only connected to E. That's what you'll see here. And for E also there is no connection. From E, you don't have any arrow going towards any other vertex, right? So that is the only change. You have to stop capturing this reverse one or directed, commented. Okay, so that is what we have done. So that is the adjacency matrix representation of the graph. Now we'll do the adjacency list. So when you are representing your graph as an adjacency list, then you can have an array of lists or list of lists or even map of list. What you do is you won't store all possible edges as we did in adjacency matrix. You will only store the actual connections. So each vertex maintains a list of its adjacent vertices. So in our graph, we saw, right, A connects to B, C, and E. So for A, you will create a list which will have B, C, and E. That's how you will do it. Since you only store actual connections, so list is more space efficient. And as I said, you can have array of list or even map of list. So you have several ways to implement adjacency list in Java. Here we'll use map and list way. I find it more intuitive. So your vertex becomes the key and you store the list, right? So that is how your adjacency list will look like for this graph, which is undirected. So from A, we have a list which has B, C, and E. From B, A, right? And so on. So with the map, these will be the keys. And as a value, with each key, you will have a list. So each key maps to a list of vertices it connects to. That is how you have to implement it. We'll create a new class, unweighted of adjacency list. All right. So again, first thing, how many private vertices, right? Now we'll have a map which can store string and a list of string. So we can directly store it as a string only. I'll name it adjacency list map, right? And get the imports. Then again, need a constructor where I'll get the vertices. So this dot vertices equal to vertices and our ADJ list map equal to new hash map, right? So that is what you will need as a basic structure. Now again, I can have the same kind of method, public void add edge, where I'll get as a string source and destination, right? What we'll do here is, since it is a map, can use compute if absent, which is a new method in Java 8. So if I have to add, say, source, if it is not there, that means I need a new array list. Otherwise, add destination. And for undirected graph, I need to do the opposite also. For undirected graph, destination, source. Right. Now I can create our graph. So again, I can get an object of this obj equal to new and 5. Then I can call add edge. So from A we have B, need it 5 times, right? So A to C, A to E. Then from C to D and D to E. C to D, D to E. Then again I can have another method to actually display it. So public void display graph. So what we can do here is it will be a hash map, right? So I can get that entry set, or that will give me map.entry. It will be string and value will be a list of string. So that is what I'll get, map.entry e, and that I'll get from this adj list map.entry set. Correct. Now I do it with an arrow, let's say. Then what I can do is e dot get e plus arrow, like this. Then I'll have another loop where I'll go through this list. List will give me a string. So string s e dot get value. On that I want in one line only. So remove this. This will be done after I come out. So system.out.println, and here what I want to show is like this, plus s plus close and one space. Then I can call method from here dot display graph. Now if I run it, I get like this, right? A B C E, B to A, C to A to D, D C E, E A D. Right? A connects to B, C and D, B connects to A, C connects to A and D, E connects to A and D. Okay, so that's how we can create a graph representation using adjacency list, where we actually use a map where each vertex is key and we get a list of connected vertices. All right. And for adding edge, I've used compute if absent method, which makes it easy to write that logic. I don't have to write it myself. Just have to give the necessary condition. If it is not there, then add the new array list. Otherwise, add to the existing source to destination. Right? So it will add for this key, this value. And reverse also we have to do for undirected graph. That's it. So that is for undirected graph. Now, if we have a directed graph, then what will happen? Let's see that. All right. So for directed graph, again, since it's one way only, so your graph will be restricted to this much now. When using adjacency list, from A you can go to B, C and D, but from B nowhere. So that is not even there now. From C you can go to D, from D you can go to E. Again from E you are not going anywhere, so that is also not there. So that is how it is more space efficient, right? Again, if I have to represent it programmatically, only change in this program which we have already written is commenting this line where we make the reverse mapping. So for directed graph, comment it. That's it. With this, we get the same thing from A, B, C, E, C to D, D to E. B and E are not there. So that is about the adjacency representation of the graph, which is done here for unweighted graph. So we have seen all the four combinations with unweighted graph, directed, undirected, along with adjacency matrix and adjacency list. Thanks for watching the video. Please don't forget to like and subscribe.